Hello Year 12. This video is going to have a look at finding areas by integration, but it's only going to look at areas enclosed by the x-axis. I will do y-axis in a separate video. Okay, let's go. So when the area is above the x-axis, the integral will be positive and the area will be equal to the integral. So here's our curve, this curving line here. We've been given an upper and lower limit. So I've got a B and an A. And when we're looking at the areas enclosed by the x-axis, it's between our curve, the line x equals A, x equals B, and the x-axis. So that shaded area is the area that we want. And this is a positive area, which we actually looked at in the last video. Have a look at the next one over here. When the area is below the x-axis, the integral will be negative. So if we're finding the answer to an integral written just like this between two limits, and it hasn't talked about area at all, it's just given us that, we're going to get a negative answer here because it's below the curve. But if the question that we're going to answer is talking about area, we basically would like to find the absolute value of the answer because we're looking at total area. Because although there's area above and there's area below, we want to add them together. So we need to be very careful about what our graph looks like and where the graph is going to be below the x-axis. And we'll have a look at that during this video. Okay, so we're reading through the notes. It says, generally we think of areas as being positive. To find the areas below the x-axis, we find the absolute value of the definite integral. Okay, and we'll do that in the questions in a moment. So there's a few steps that we need to do. We want to sketch or draw the function that we've been given. And I want you to try and do that with most of your questions anyway. So you're really not getting confused. You know what you're looking at. We want to show the intercepts and the intersections. We need to particularly show our x-intercepts because that's going to give us what our x equal A is and what our x is equal to B is. It's going to give us our A and our B, which are our upper and our lower limits when we're bounded by the x-axis for the area. So step 1, sketch. Step 2, evaluate the definite integral or definite integrals, because we might have two parts depending on whether or not we are above or below the x-axis. And finish by writing your area answer in square units. So there was a few questions that have been brought up in the last couple of lessons at school. So when the question talks specifically about area and finding the area, we want our answer to have square units. When our question is just looking at working out an integral, algebraically, we don't need the square units in there. So we need to be people that are reading the questions and doing what the question is asking us and being very careful about that. Okay, let's look at the first example. Find the area enclosed by the curve y equals 9 minus x squared and the x-axis. So the key things in there are area, there's our function, and the x-axis. This video is relating to purely the x-axis. So in this case, we're only looking at the x-axis, but our next one will have a look at the y-axis as well. So the region that we need is going to be slightly different. So there are three things, okay? If you're not reading the question correct, you will not get that. So step 1 was that we needed to sketch this diagram. So we need to look at where that is going to cut the x-axis because that's going to give us our upper and our lower limits for our integral. So where does this cut the x-axis? It cuts the x-axis when y equals 0. So we're going to have 9 minus x squared is equal to 0. You've got two options. You can either pop the x on the other side and take the square root of 9 and get plus or minus 3, or you might see it's a difference of 2 squares, in which case you're still going to get plus or minus 3. Okay, and you should be quite familiar with doing that now. That's where it cuts the x-axis. Where does it cut the y-axis? It cuts the y-axis at x equals 0, so it's going to cut the y-axis at 9. So let's sketch that and pop that information on our graph. Pause it if you need to. Okay, let's change colors. So we're cutting at minus 3, we're cutting at 3, and we're cutting at 9. Now, we need to have a look at what the graph is saying. The graph is 9 minus x squared. We're also thinking of it as minus x squared plus 9. So if we think back to our first chapter for year 12, It's a negative parabola, so it's going to be going that direction, and it's moved up to 9, so it's moved up here, and it's going to cut the x-axis at -3 and at 3. So part of our curve sketching that we've worked through, you should be very familiar with that now. Now, the question has asked us to find the area enclosed by the curve. So here's our curve and the x-axis. So it goes down to -3 and up to -3. So we want, oops, I'll just fix that up again. We would like this section above the x-axis. Sorry, my pen is deleting what I'm doing here. Okay, so we only want this red hashed section here. So we need to write our own integral now. Okay, so what we want to find is the area in here. We need to think what we're doing. So there's actually a couple of ways to do this. We can go between 3 and -3 of 9 minus x squared dx. Okay, so we've put our limits in. It's finding the area under the curve, so that's okay. Our curve meets the x-axis, we're all good. And we can integrate this. However, there's actually a little bit of an easier way using our notes from yesterday. If we think of this as an even function, all we want to do is integrate this section here between 3 and 0, and I'm going to double it because it's an even function. So you don't need to do that. The reason I'm going to do that is it gives me a 0 as a lower limit. So when I'm substituting into my function, it just makes it the multiplication just a little bit easier, but you will get the same answer. So if you want to do it your way, that's okay, and you can check your answer with me. Okay, so let's integrate our function. We're going to have adding 1 to the index becomes 9x, adding 1 to the index here, and dividing. Okay, now we're going to pop in our values. Okay, so I'm going to pop my 3 in first, so I get 9 times 3 minus 3 cubed on 3. That's our first bit. I want to pop another bracket around there. Minus what I get when I pop 0 in. Well, that's going to be 0 minus 0, so it's just 0. And that's the bit that makes it easier, okay, because I'm doubling this answer as opposed to not having the 2 and popping -3 down here and then having to put -3 in there. So a little bit quicker for you. So I'm going to have 2 times 9 3s are 27. 3 to the power of 3 is 3 times 3 times 3, which is 27, divided by 3, which is 9. 27 take away 9 is 18, and that's times 2, which is 36. This is units squared. Okay, the question was looking at finding the area under the curve. Area is in units squared, or you can write them as u squared. That's okay as well. Now, again, I just want to confirm that you understand that this question is looking at area. It wants us to have units squared. If my question solely and only asked this part in red, did not talk about any areas and just asked to solve this question, you would have an answer of 36, in which case you don't need your units squared in there. But in this case, we do. Okay, I want you to go to the next question now. Finding the area enclosed between the curve y equals x cubed, the x-axis and the lines x equals 1 and x equals 2. So we need to sketch this first. We always need to sketch this so we get the right idea of what we're trying to equate. Now, y equals x cubed. Fairly straightforward. You should know that graph. Okay, it's going to cut at 0, 0. It's going to look like this, and it's going to go down like this. This is an odd function. Okay, a lot of the time in your tests, you're going to be asked to show something's odd. In this case, we know this is odd, so we are not needing to test that. I'm going to put some values in here because we've got some numbers that are our bounds. We've got 1 and 2, -1 and -2, and we have been asked to do it between x is equal to -1, so we're down here, and x is equal to 2, so we're up here. So now let's read the question again and just confirm we know what we're doing. We're going to find the area. Okay, area means we're in units squared. We are going to find the area enclosed between the curve, y equals x cubed, the x-axis, and these two values, which we've drawn in there. They're my green parts. Now, what we want to do with this question is you want to think about this. Okay, previously when we've integrated a function, or integrated x cubed, and I'll show you that in a moment, our positive is basically, I guess, deleted against some of this negative part of the curve. So we would have this part cancelling out with, oops, that part in there, and we'd end up with 0 in that section if we were between 1 and -1. But that's when we're integrating algebraically and we've not been asked to deal with area. So what we're going to do here, I'll just get rid of those bright blue parts, is we're going to think what that means. If we're looking at area, we've got area above the curve and we've got area below the curve. We are going to integrate these two different intervals separately, and we're going to add our answers together. So we need to be very careful that we have a diagram that is accurate and that we can do that. So we're going to do that now. So if you want to pause the video and have a go, please do that. But what we're basically going to do, we'll set up our integrals. My first one is between 0 and -1, which is the part below the curve. Okay, there's my curve in this interval. And I'm going to add to that the part of my curve between 2 and 0. I need to do my parts above and below the curve separately, otherwise my answer will be different than it would otherwise be if we were just looking at an algebra integral question. So let's figure out our answers. Okay, remember your square brackets. Remember, we don't need a plus c because we've got values in there. When I integrate my x cubed, I get x4 on 4. And when I integrate, pop in the square brackets again, my x cubed over here, I'm going to get x to the power of 4 on 4. So we need to put our values in. Okay, so this is the part that is below the x-axis. This is the part that is above the x-axis. Let's pop these values in and work this bit out first. So I'm going to have 0 to the 4 on 4. 0 to the 4 is obviously 0. Minus, got -1 to the power of 4 on 4. I probably didn't need those little brackets around there. Oops. Okay, that's my first bit. And I'm going to add to that what I have over here. I'm going to pop 2 in there first. So I'm going to have 2 to the 4 on 4. Take away, pop our 0 in, 0 to the 4 on 4. So let's see what we get. 0 actually, and we need to make sure that we get these values here to become positive. So 0 to the 4 is just 0, and I'm going to have minus 1 to the 4 is 1, and 4. So I want to take the absolute value of the part below. I want to take the absolute value of that because I want a value that's not negative. And I'm going to add to that my values on this side. 2 to the 4 is 2 2s are 4, 4, 2s are 8, 8 2s are 16 on 4, which is 4 minus 0. So on this side, I'm going to have a quarter, and on this side, I'm going to have 4. So my total area is 4 1/4. So I'm going to highlight that I've taken the absolute value there and there and there, because the area below the curve was a quarter. It came up when we integrated as -1/4, but we want the area. So area can't be negative. Let's just take the positive. So it gives us a total area. Now, what I want to do is show you to the side. Now, you might want to pop this into a blank page. You should have, if you scroll down, you'll have another blank page down there. So if you want to go there and just pop this down there, I'm going to pop it to the side. I want to have a look at what we would get as an answer if I was just to integrate between 2 and -1 of my x cubed in relation to x. So what we've done here, but instead of popping my two sections, which are below and above, I've just put it straight up. And that was what we did a couple of exercises ago. This is basically just saying, solve this integral. We're not being asked to graph it. We're not asked to find the area. We're just saying to solve that. So in this case, what we would do is we would pop our values in here. We don't have a plus c because we've got a definite values in here. So if I was to then integrate, I'd get x to the 4 on 4. My answer would be 2 to the 4 on 4 minus -1 to the 4 on 4, which is going to be 2 to the 4 is 16 on 4, which is 4, minus -1 to the 4 is 1, so 4 minus a quarter. So I'm going to get 3 3/4. Note, my answers are different, and that is correct. The difference being we've just done this algebraically. We've not looked at area. It's just giving us the net, I guess, area under the curve. So it's given us this area here, take away this area here. But if we're wanting to work the area out as an actual practical question, we need to add them together, and we're going to get 4 1/4.